Good afternoon to you. Mark Sudduth, HurricaneTrack.com, here with your Hurricane Outlook and discussion for Friday, the 29th of July, 2016. Topic of interest in the Atlantic Basin continues to be 97L here, 96L here. And just real quick, I know I've said this a few times, but for any new viewers, I want to recap as briefly as possible. What in the world does a 96L and a 97L even mean? Well, basically, when there's an area of disturbed weather, the National Hurricane Center will designate it once it reaches a certain threshold, and that's somewhat ambiguous as to when it reaches that threshold. It gets a number, 90 through 99, and the letter L for Atlantic to designate it as a special area of investigation, and then they get to throw computer models at it, satellite floaters, task recon if they want to have the hurricane hunters fly out there, etc. It's just a way to keep from calling everything a blob of clouds or a tropical wave or a tropical disturbance. These are sort of the first steps, these numbering and letter systems, 90 through 99, and again the letter L, in the process of potentially having a named storm. So this one is 97L because it was designated that a little bit after this was designated as 96. So let's take a look at the satellite picture. So here we have 97L right here, and it's a pretty well-developed high-amplitude tropical wave in the atmosphere. A little bit of convection or thunderstorm activity trying to develop. That will help to gradually lower the pressures. With this system, it's not completely naked of any convective activity, but you do have a pretty dry air mass with the Saharan Air layer up here. You can see that clearly by the look of the cloud cover. This sort of milky white color really screams dry, stable air, and you can see there's no convective activity in here at all, and that's the reason why. It's a fairly warm layer of the atmosphere involved in here, and no moisture to speak of is able to really percolate through that from the surface, where it certainly is warm and humid. But still, with the wave itself trying to get itself together, it's moving fairly briskly. Interest here in the Leeward Islands and parts of the Caribbean are going to have to watch this because it will bring the potential for gusty winds, and some of these thunderstorm downbursts can produce tropical storm force winds, very heavy rain, and in some cases frequent lightning, especially when these things are in their formative stages. But you can tell it's trying to wrap in moisture with its sort of feeder band here, if you want to call it that, really the front runner of the surge of the moisture and the energy package, but it is trying to wrap it up. You see it's making some progress. Luckily for interest in the Lesser Antilles, it's slow going, but this will move on into the Caribbean and beyond, and it might try to develop somewhere over here, so we'll have to watch that in about a week's time. Meanwhile, off the screen here, we'll take a look at it closer on a different perspective in a minute, is 96L. In the Eastern Pacific, this one is 91, if I can draw this, E, and the E here, of course, means Eastern Pacific. I'm using a mouse to draw, so it's hard to do sometimes. Better to telestrate than to actually draw letters and stuff. But this is 91E, and you can see it's got a high chance of development, staying well away from the Baja and Pacific Mexico as a whole. That broken record continues, but that's a good broken record because I'm sure folks along the Mexican coast would just rather not have hurricanes at all, and so far they're all staying well away. This is another system with a low potential for development. In fact, as we've been talking about for several weeks now, this entire region has been very fertile so far once it got going. Agatha being the first, ended up with Georgette as the last, and this will probably be the next one in the East Pacific. So again, a wider perspective here. The tropical wave designated as 97L here. This is 96L, a little bit more concentrated, certainly sort of has an S shape to it. And that shows me, you see these little bands here trying to get together. It's trying, it's definitely trying, but the vertical instability is almost where it needs to be. But I found something, looking around today that I think explains a little bit better why these systems aren't developing right now. I see a lot of tweets out there saying such and such tropical waves, 96, 97L, doing this, doing that. But dry air will inhibit development, etc. It's all being blamed on dry air. Well, I'll show you in a minute that I don't think that's all entirely the case. Now, certainly just to the north of the circulation here, and there is a weak circulation with area 96L some of that dry air probably getting ingested. You got to remember, when these things start to develop, tropical cyclones, they have upward motion to them, right? They're developing deep thunderstorms, and that's converging air, so that air has to come in counterclockwise from all different directions in a perfect world towards that center of lowering pressure. And so when these start to ingest that air and inflate themselves, if you will, they're pulling in whatever air is around them. And if some of that air is drier and it's tapping into that Saharan air layer even a little bit, that's enough to start to squash these systems or limit convective activity or the development of thunderstorms. Less in the way of Saharan air intrusion and involvement. And boy, you can really see the sharp edge of the surge of, this is moisture in here, believe it or not. That's why there's no SAL or Saharan air layer indicated. But this is moving fairly briskly, so it's kind of battling itself. It needs to slow down so it can converge upon itself, almost literally, and then grow. But again, I don't think it's going to do that. So Saharan air influence may be a little bit of the issue with some of these systems, chances for development, but I don't think that's the overall issue. Certainly the vertical wind shear, below normal right now over the tropical Atlantic. You can see there, been below normal for a while overall. And then here is the vertical instability. I showed this yesterday, and it was about here. And look, we are almost at the climatological norm. In other words, the vertical instability in the atmosphere, or the ability for an air parcel to lift into colder air aloft, is one way to look at it. It's really not that far from normal. In fact, it's made a pretty big leap upwards towards the climatological mean here. And so you can't point to dry air necessarily as the culprit here, or the lack of instability. Some of those go hand in hand there. The dry air certainly puts a limit on that vertical instability. Moreover, I think that it has to do with the Madden-Julian oscillation and what we call these convectively coupled Kelvin waves. Michael Ventris, Dr. Ventris from the WSI, he knows a lot more about this than I do. You should follow, I think it's, well, just look up Michael Ventris, Ventrice, on Twitter, and you'll know who I'm talking about as soon as you find him. He knows a lot more about the tropical intraseasonal variability of these CCKWs and convectively coupled Kelvin waves than I do. So I try to look at the more simple, bigger picture to explain things. And basically, I think what we have here, it's clear to see from this, those of us who know this graphic, green is generally upward motion in the atmosphere, which allows thunderstorms to vertically go up and spread out evenly and all that kind of stuff. This promotes vertical motion in the atmosphere. The brown suppresses it, the Madden-Julian oscillation, or the vertical velocity in the atmosphere at the 200 millibar level. And again, the simplest way to look at it, brown is generally no-go for development, green is favorable for development, upward motion in the atmosphere. So 97L is located right in here somewhere, and 96L over here. So we're really not seeing much in the way of helpful upward motion in the Atlantic Basin. In other words, the air is much more sinking and suppressing convection, and you can clearly see that in the satellite picture here. It's not as what is the word I'm looking for? Hostile, there we go, as it has been, because yeah, we're developing some thunderstorm activity, but wait until you see this graphic, or the satellite picture, when this shows a bunch of green over the Atlantic Basin. And it eventually will happen, I do believe, as we move through the season. But right now, I think that big inhibitor is the overall sinking motion, or the suppressed convective atmosphere, if you will. The environmental conditions they're just not there. You have low wind shear, vertical instability is certainly improved, but the ability of the atmosphere to go up and to develop those thunderstorms, it's kind of a hand pressing down almost. It's being suppressed right now is the easiest way to explain it. So great news if you live in the islands, you don't have any hurricanes headed your way. But again, if you're in the Lesser Antilles, be on the lookout for that tropical wave that's associated with 97L as it moves through, and we'll keep an eye on it and see what happens in the Caribbean next week. As I say, these don't just go away. We may have to deal with them later, if not sooner. All right, well, that's it for me for today. Have a great rest of your Friday afternoon, and thanks as always for tuning in. I am Mark Sudduth for HurricaneTrack.com, and I'll talk to you again tomorrow.